Unit 7 covers piping, tubing. We're going to cover a lot of this in class, so I'm not going to spend a ton of time going through it, but did kind of want to go through the textbook stuff just real quick. Now, this is this is 7th edition, but pretty much same information. And so I'm going to start this. Okay, so when we're talking about tubing, we're talking about the copper line sets that you're using to run your refrigerant through. So you've got a small line and a larger line, and these are going to be used to transfer refrigerant back and forth from the outdoor unit to the indoor unit in a regular split system. So you've got an air handler inside somewhere, and you've got an outdoor unit. Um, so we're calling that tubing. Tubing and piping are similar, but they're a little bit different. I'm not going to get super in depth on that, but most of the time we're using copper, but there are different types of copper. So the K type is a heavy type. L type is a standard weight. M and DWV are lighter. So sometimes you'll notice if you buy a line set or you're dealing with maybe a change out or something, that sometimes the copper that you get seems thinner and it seems like it wants to bend and kink easier. So there are different qualities, different weights of that. So you're going to be dealing with ACR copper, which is your air conditioning rated stuff. Um, it's different than plumbing copper, and so this next slide is going to show how that is. So your ACR copper is going to be measured um, by outside diameter. And so what that means is you go to a parts house and you ask for half-inch copper tubing or half-inch copper pipe. If they're going by plumbing sizes, then they're going to go with ID or inside diameter. If you're dealing with ACR stuff, you're dealing with OD. So if you're looking for fittings, for example, this is probably the biggest place. You're looking for elbows, couplings, that kind of stuff, reducers. So if you're trying to stock up your truck and you're ordering some stuff, a lot of these places carry plumbing and HVAC parts and supplies. So you'll need to make sure that you're letting them know that you're wanting ACR tubing. They should know what you're talking about. But if you are looking for it, you're going to be dealing with 3/4 inch, 7/8, that kind of stuff. But that's going by the outside diameter of the pipe, not the inside. And so if you were to put 3/4 inch ACR next to 3/4 inch plumbing, the plumbing would be a lot bigger. 3/4 inch plumbing pipe is pretty large, versus a 3/4 inch ACR is not that big, about the size of probably one of your fingers, or maybe a little bit bigger than that. So to stick inside of it. So 3/4 inch PVC, for example, uh, is probably the diameter of a quarter on the inside. So just to kind of give you an idea of the difference in size there. So they are different. All right, so when you get these in a bundle, it's going to be called a line set, and that means basically it's a set of lines. The larger one is going to be insulated, and there are different grades of insulation. So if you're dealing with new installation or something that's going to go through an inspection, it may have to have a certain thickness of insulation versus one that's not going to go through that. May not have to meet those standards. You can just go with a standard insulation on that. So make sure that you're aware of your codes and your regulations on that as well. Um, there are pre-charge line sets, but usually we're not dealing with that kind of stuff. That's more DIY stuff or mobile home type stuff. Um, okay, so I would recommend to cut with a tubing cutter if at all possible. However, if you get into some larger applications where you're dealing with 2, 3, 4 inch pipe, commercial stuff, um, you may have to use some other sort of saw or something. But usually, you want to try to get away from cutting because you're going to get those shavings inside of your piping. Once you get over, I'm going to say inch and an eighth. I've never seen anything larger than that in soft drawn tubing. So soft drawn means that it's bendable, that it's going to come in a roll. So there is straight rigid pipe, which is going to be pipe sections. That can't be bent. So the only stuff you can bend is soft drawn tubing that's going to come in a roll. It's bendable. Um, but usually the largest I've ever seen with that is like 1.1 inch. But that's pretty large, even at that. Your two common sizes of suction are 3/4 and 7/8 on residential. Occasionally you'll see 1.1 inch. I've seen some old stuff that might have 5/8, but that's pretty odd. Your liquid line is typically 3/8. I've occasionally saw 1/4. So some of your older units, especially Reams and Temp Stars, they had 1/4 inch fittings on them, 20 years ago. And if you go to do a change out and, let's just say you can't remove that line. So if at all possible, you want to remove the line. But if you just absolutely cannot replace the line, I've ran into situations to where you need to replace that 1/4 inch line with a 3/8 because you're using a newer refrigerant that runs at different pressures. And sometimes it's just absolutely not possible. So if you get in that situation to where you didn't bid a new line and then now you need one and it's going to take a lot more work to get it ran, then you're losing money. So if you're there looking at that change out, for example, make sure that you're looking at all that stuff. And if at all possible, change the line set. It's just good practice. You can bend that stuff. You can use a bender. We've got some of those in the shop, so we may use those in class. All right, so to give you an example of the difference in terms, a lot of people will call what we do soldering, and I mean that's fine if that's what that's what I call it a lot of times too. But technically, if we're brazing with an oxyacetylene system, oxygen and acetylene, or an acetylene system, you're going to be technically brazing, which happens between 1205 and 1550 degrees. So all these terms is just the temperature at which it takes place. Welding is just at a higher temperature as well. So once you get to a certain point, you're technically brazing, not soldering. Soldering is more a low temp application, a lot of times reserved for plumbing, but there are some types of solder, I guess you would say, that like Stay-Brite, that can be used for refrigeration, and it can be done at a lot lower temp, and with a different gas you can probably get it hot enough. But what we're talking about in class is going to be considered brazing. Most of what we're going to use is a silver alloy brazing. So brazing is done in the 800 degree range. You're melting it into the gap. So if you ever done plumbing solder, the big thing you're trying to do is you're trying to suck that back to the back side of the pipe. And so here's an example of that. So you sometimes won't even see the solder on the leading edge. Now, we're still doing that in brazing, but it's not quite as pronounced. So when you're soldering a plumbing pipe, you're actually sealing on the inside, not on the outside. So if somebody who's a good solderer, you may not even see the solder at all, but it's sealed on the inside. Plumbing solder is a lot thinner and it runs a lot quicker and easier back inside of that fitting. And so what you'll do is you'll actually heat that on the back side of the fitting, because remember, your heat's going to draw that solder wherever it needs to go. So you're going to heat toward the back and it's going to draw that up inside. We want to do that with brazing as well, but it's just not going to be quite as pronounced. And just me personally, I want to pull that back inside some to make sure I'm getting a good seal, because if you look at that, if you solder all the way up that fitting on the inside of that fitting, then you've got a lot of surface area of your filler material. But I want to make sure that that leading edge is covered as well. So I would rather see it, maybe standing up just a little bit so that I don't see any holes, versus that it looks like there's no solder there and maybe looks a little better, but I want to make sure that it's sealed on that surface. So that's just me. We're using brazing alloys. Usually it's a 15% silver content, but there are different rods for different applications. Most of the torches that we're going to use are acetylene based for brazing. You can use air acetylene, which is what people are going to call a turbo torch, and we kind of talk about that a little bit. But most of what I would recommend, and most of your better techs are going to use, is oxyacetylene. So they're going to use an oxygen tank and an acetylene tank, and it's going to mix those two at the torch, which gives you good combustion. and it makes it burn hotter and more direct. But there's a little more of a learning curve with those than there is with a turbo torch. So we'll work on in class, going through and setting your gauges and learning how to do all that. Fluxing, if you've done plumbing solder, you would add a flux. Usually we don't deal with a flux in ACR copper. It just doesn't seem to be needed. There is a flux that you can get for that. Main is just to prevent oxidation from forming on the surface. And it helps it flow a little smoother. So it's like this paste that you put on if you're doing plumbing solder, and then as it heats up, it kind of becomes a liquid, and it helps that solder run with it. So you'll see in this next slide, you see how they're heating toward the top of the joint. They're pulling that solder. So this is actually soldering. This is plumbing solder, or it appears to be. And so they're using a lower heat, and they're going to pull that solder up inside. Brazing, the biggest thing is you want to make sure that it's clean. Keep a sandcloth, plumber's sandcloth, something like that to keep the end of that clean. The insides, you can get a little brush that'll go up inside of that as well. If it's new fittings, usually you're in pretty good shape, but sometimes you're working with old stuff, so you want to make sure that you clean that completely, and that it's free of burrs and that kind of stuff when you're putting it up in there. And then you just want to heat it. You're going to introduce a little bit of nitrogen to the system. You're going to flow nitrogen if at all possible. That gets rid of that oxide buildup, and we'll go over that in class. And there's a lot of materials on that in this module, so I'm not going to spend any time on that. But basically what the nitrogen does is it displaces the oxygen. So when you get rid of the oxygen, that stops the reaction between the heated copper, and the oxygen, which creates copper oxide. That's the flaking, the scale that you see come off of the piping. So if you flow nitrogen through that system, then you're going to get none of that. You're going to have clean copper on the inside, and that's what you want. So those flakes don't make their way into your filter dryer and your TXVs and little openings and stuff like that. You want to heat everything uniformly. You want to try to work your way around it, and we'll go over all those techniques in lab. And then this says to heat it when its temperature is cherry red. I'm probably not getting it that hot on the whole pipe. If you get it that hot with an oxyacetylene torch, you're probably going to start blowing holes in it. Now, if you're using acetylene and air turbo torch, then yeah, you'll probably get that cherry red. But you're just not going to be able to get the whole thing that red, in my experience. And then flares, I'm not going to spend a bunch of time on this, but flare fittings, you'll see these on mini splits. So we may talk about this a little bit in class, how to make a flare, so on and so forth. Swaging, this is something we're going to do quite a bit, and we've actually got some better ways of doing that than they're talking about here, using a swaging block and stuff. But swaging reduces removes the need for a fitting. So that's one of the big advantages, is I don't have to have a coupling. I'm not at the mercy of a coupling. Plus, if I swage it, basically what you're doing is you're swelling out the end of that one to make a female fitting that would go over the male end of that pipe. And so you're just making one joint versus two, which means half the solder joints, half the places for leaks. So all of those things are good. Compression fittings, you won't see these in air conditioning really. You'll see this more in pneumatics, water. So I'm not going to spend much time on that. Rod arm pipe, we'll go over that more in your gas class, how to fit pipe and stuff. Plastic piping, CPVC, PVC, all that stuff. The main thing you're probably going to use in air conditioning is PVC. That's used for your drains. That's the white plastic pipe. CPVC is actually measured, so it's weird because PVC is a different. Let's see. I'm trying to think how to explain this. So PVC is usually used for our drains. CPVC is the little kind of off